Hello guys, well, who speaks to you is Gustavo Chiera, Mechanical Electrical Engineering in Lima, Peru. My code zip is 221359. Today we are talking about the second topic about trigonometry, that is a length of arc in the circumference and circular sector and trapeze area. First of all, I would like to say to you that if you can understand something, just let me know, because it's a good way in that I can improve my English, especially because I'm from Peru, so my English is not so good, but I try to do my best. So let's go to the class. Okay, guys. In this topic, I'm going to teach you three terms. That is length of arc of the circumference, definition of the circular sector, and a sector circular trapeze. This is very important to know because you can use all these expressions in the area of engineering that actually I'm working. So let's go to the next slide. Okay, in this slide, we can see the length of the arc in the circumference. So in the picture, we can see a circumference and the parts of it. We find the vertex, the initial side, the end side, the measure of trigonometric angle, obviously in circular systems, in radian. L, that is the length of arc, and S, that is the area of this circular sector. Well, that's the expression that we need to know is that the length of arc is equal to the angle theta multiply the radio r. Well, the area of this sector is very similar to the area of a triangle, that is equal to base multiply the alture divided by 2. So it's very easy, because we can find this three expression, but it's not necessary memorize all the expression, because if you know this and this, you can find the other one. Well, replace L equal to theta multiply R. We get that the area is equal to theta multiply R divided by 2. And this is, reduced expression is equal to theta multiply R squared divided by 2. So in the same way, if you multiply the theta here and here, you can find the expression L squared divided by 2 theta. So this is the two expression that we are going to know in order to resolve any problem. Well, in this slide, I'm talking about the area of a region bounded by a circular trapeze. So is that I said it's very easy, because the area is equal to a trapeze, ordinal trapeze. So in the only thing that we are going to add is the expressions in the last slide. That's just that, only that. Don't confuse, don't worry about this, because it's very easy. Well, the arc L1 is equal to theta multiply R. The arc L2 is equal to theta multiply R, and so the area is equal to a ordinal trapeze. So that is equal to the first side plus second side, the measure obviously, divided by 2 multiply the height. So in the same way, the area of this region is equal to L1 plus L2, the length of arc, divided by 2, multiply the height. In this case, the height is r minus r, obviously. So replace the expression of L1 and L2. We find, or we see that the area is equal to theta multiply r plus theta multiply r divided by 2, and all multiply r minus r. So factorize, we can see that the expression is equal to theta multiply r plus r multiply r minus r divided by 2. The final expression, or this area, is equal to theta multiply r square minus r square divided by 2. Obviously, remember that the angle is the measure is in the circular system, just that. So this topic is very easy, and this is the only expression that we can use in order to resolve any problem. So now I'm going to resolve 4 problems using the expression that I can explain. Sorry, that I explained. Okay, the first problem. So in the figure showing AUB and COD are circular sectors that we can see, where the areas of AOB and ABC and D regions are in the relationship 25 to 24. In addition, lengths of arc AB and C and D add up 24 centimeters. Calculate the length in centimeters, obviously, of the arc AB. So the firstly, using using the condition, we can see that in the picture the arc AB plus the arc CD is equal to 24. So in that case, AB, we can write that the arc AB is equal to x and the arc CD is equal to 24 minus x. And in this way, the expression that the plus of this arc are 24. Sorry, is 24. So we can write in the picture in order to get a solution. So remember that the angle A or B is equal to theta radian. Well, the next step is that from the statement, the area AOB and the area ABCD is in the relationship 25 to 24. So this is a reason that we know in arithmetica, obviously, and well, we need to complete using this expression. So the area AOB is equal to 25s and the area ABCD is equal to 24s. So remember that the circular sector, the expression that we need to use is the expression or formula that use the length of arc and the angle. And well, this expression is this: the area of AOB is equal to the length of arc square divided by 2 theta. Well, replace the values, so we get that 25s is equal to x squared divided by 2 theta. Well, in the same way, in the circular sector COD, using the same expression, we find that 39s is equal to 24 minus x all square divided by 2 theta. So in that case, we need to divide it 1 divided by 2. Okay, we divided because this is the only way that we can simplify the expression s. That is not necessary find the answer of s. Well, divided, we get the 25 divided by 49 is equal to x squared divided by 24 minus x squared. So the reduced expression, we get that 5 divided by 7 is equal to x divided by 24 minus x. And well, reduce the expression, we get that 120 minus 5x is equal to 7x. Well, reduce all the expression, we get that 120 is equal to 12x. And finally, the value of x that is the arc AB is equal to 10. So finally, the answer of this problem is the letter C, the value of 10. Okay, problem number 2. In the graph showing AOB and COD are sector circular, the area of A, B, C, and D region is equal to 3 times the area AOB, sorry, of this region, and the length of arc AB is 4 units. Calculate the arc length DC in unit. So in the picture, AB is 4 and CD is equal to L. So right in the picture, remember that the angle AOB is equal to theta radian. So okay, from the statement, the regions is AOB and ABCD are in the relationship 1 and 3, because said that the region ABCD is equal 3 times the region AOC. So in the same way as the problem number 1, the expression or formula that we need to use is using the length of arc and the angle. So the area AOB is equal to the length of arc squared divided by 2 radian. Well, replace values, we get S is equal to 4 squared divided by 2 theta. Well, in the same way, in the circular sector COD, we get that 4s s plus 3s is equal to L squared divided by 2 theta. So divided 2 by 1, we get that 4 divided by 1 is equal to L squared divided by 4 squared. Reduce the expression, we get the expression of L squared is equal to 2/6, and reducing that, we get that the length of CD is equal to 8 units. Well, the answer of this problem is the letter B, that is 8 units. Okay, problem number 3. If S1, the area of the circular sector COD, and S2 is the area of the circular trapeze A, B, C, and D, also it knows that S2 is equal to twice S1 plus 8. Calculate S1 in square unit. So the angle of the measure of AOB is equal to theta radian. From the statement, in the same way, S2 is equal to twice S1 plus 8. Well, expression number 1, the circular sector AOB is equal to S1 the arc square divided by 2 theta. Well, the second expression that the circular sector COD is that the area S1 plus S2 is equal to 3L squared divided by 2 theta. Well, 2 divided by 1 is the expression finally is that S1 plus S2 is divided by S1 is equal to 3L squared divided by L squared. So reducing the expression and always using this statement, we get that S1 plus 2S1 plus 8 divided by S1 is equal to 9. Well, okay, we get finally that S1 plus 2S1 plus 8 is equal to 9S1. Well, reducing the expression, we get that 8 is equal to 6S1, and finally the region S1 is equal to 4 divided by 3 square unit. Well, finally the expression of the area is the letter C, 4 divided by 3 square units. Okay, finally the problem number 4, that is have a little difficult but not impossible. Well, the figure is showing AOB, COD, and EOF are circular sectors where OA, the side OA is equal to BC and equal to DE. It's also knowing that the areas of the AOB, BCDI, and DEFG are proportional to 3, 6, and 20. Find the measure of the angle COD. Well, the first conditional set that the side AOA, BC, and DE is equal. So we can we can set that the side is equal to a value R. Well, from this statement, we get that the areas, that these areas are proportional to 3, 6, and 20. And so in the same way, we need to complete with this statement in the correct side. Well, the area AOB is equal to 3S. The area BCDI is 6S, and finally the area DEFG is equal to 20S. Well, circular sector COD. In this circular sector, we need to use in the same way the expressions. In this expression, we need to use the formula that only use the angle and the radio. Well, in that case, the circular sector COD is equal to the angle multiply the radio square divided by 2. Well, replace the area BOI plus 6S is equal to theta multiply 2R square divided by 2. Now the circular sector BOE is equal in the same way the angle multiply R square divided by 2, and so now using this expression and this other expression divided, we get that SBOE plus 6S divided by the area BOE is equal to 4. So finally we get that this area is equal to 2s, and well, we need to complete 2s. The next step, circular sector EOF. In this circular sector, using the same formula, we get that the area of EOH plus DEHG plus 20s is equal to the angle multiply 3r square divided by 2. So in the same way, in this circular sector DOG, we get this expression, that the plus of that these areas, this and this, is equal to the angle, the same angle multiply 2r square divided by 2. So in the circular sector EOH, we get that this area is equal to theta multiply r square divided by 2. And so now, using this expression and this, we get that the area of the circular EOH plus DIHG divided by the area EOH is equal to 4. And so, reducing the expression, we get that the area of this trapezoid sector is 3 times this circular sector. So finally, we need to use this expression and this expression, because now we know that the relationship between the trapezoid area and the circular sector. Well, replace, we get that 4s EOH plus 20s divided by 4 IOH is equal to 9 divided by 4. So reducing that expression, we get that the area of this circular sector is equal to 4s. So now we need to complete all the values that we know in order to get the measure of the angle. So complete this and this, and so okay, now we get all the values of the areas, and we need to get the angle. We know that this angle is 90 degrees because in the picture we can see that, well, using a reason, the measure of the angle BOI, that is equal of the angle COD divided by 2s is equal to the measure of the angle AOH divided by 3 plus 2 plus 4, and that is 9s. So reducing this expression, we get that the measure of the angle divided by 2s is equal to 90 degrees divided by 9s. And finally we get that the angle COD or BOI is equal to 20 degrees. Well, in that case, the answer is 20 degrees, and the answer of this problem is the letter B. It looks very complicated, but no, is the only you only need to resolve step by step, because if you using formula is very complicated. You need to get an order in order to get a solution. Okay, okay guys, this is that's all for this week. I hope that you enjoy this topic because I like it. I using in my life, in my career, and obviously in the in not necessarily in the school. You use that expression in the university, in any career, especially engineering, obviously, no. And so I would like to say you I like to say Merry Christmas, and don't forget to like the video and subscribe to the channel for more topics. The next week I'm going to upload another video about another topic of trigonometry. Bye, see ya, and good luck. Thank you very much. Don't forget that you can write to me about any question, not especially of this topic, trigonometry. You can write to me about physics or another area. I oh, I am an engineering in the way that I can explain something. Uh, it it could be very it could it will be very useful for me because it's a good way in order to get with the language, not something prepare this slide. My English is not so good, but I try to do my best. So thank you very much and Merry Christmas for everybody. Bye.